All right, guys. So up to question 31. So question 31, we got one of these dome questions. Okay, compared to the sun's apparent path on June 21st, the sun's apparent path on December 21st at this location will be. Okay, so we need to know what the location is first. So if you look at the top, now you should have to read it. It tells you this is happening in New York State. Cool. So the fact that we know it's happening in New York State, we should know a whole bunch of things. Okay, we should know this picture. Dun-da-da. Okay, we should know that this big, long, black arc is going to represent the summer solstice. We should know that the blue arc is going to represent both equinoxes. And we should know that the red arc is going to represent the winter solstice. Dun-da-da. Okay, so this question is asking us, this is June 21st. Which one of those is June 21st? The summer solstice, the black arc. Compare it to the December solstice, which would be the red arc. How do those two compare to each other? Okay, they are shorter, right? It's not as long of a line, which means the daylight is not going to last as long. Okay, and if we look at how high the noon sun climbs, it climbs much, much lower between the black and the red. Therefore, the correct answer for this one should be, it will be shorter and lower in the sky.
All right, guys, so Foucault pendulum. That was the video that we showed you of the pendulum, and the guy decided to take his kids to the museum for the day, and you could hear them all excited, right? So that's when the pendulum is basically hitting the little things off to the side, and the Coriolis effect. What are they proving? Automatically, they don't prove the tilts of the axis. They don't prove elliptical orbit. They don't prove revolution. They prove that the Earth rotates. So you want to make sure that you just memorize that.
The plug was bothering Mrs. G.
Yes, it is. Go ahead.
33. Planetary winds in the northern hemisphere are deflected to the right. Okay, this is just memorization, guys. Everything gets deflected. Why? Because the Earth rotates. And what do we call that effect? We call it the Coriolis effect. This is just memory. Okay, this is everybody's favorite question. Time questions. When the local time at location C is 3 p.m., the local time at location D is... What do we do? What do we do? Remember, local time is dependent on your longitude. Only your longitude. Longitude are the long lines that run from pole to pole. So if we look here, okay, the lines of longitude, a couple of them are labeled for you. Okay, so if you see, you've got that line is 150, right? And then that line is 120. So that how far apart are those? There's 30 degrees between those. And how many lines are there? Okay? There's 2 lines. So what does that mean? That means each line represents 15 degrees. This is important. You should remember that when we talk about time zones are every 15 degrees apart is a difference in time zones. So how far apart are C and D? C and D are not 15 degrees apart. They are 30 degrees apart on this chart, meaning 2 time zones.
15 degrees per 1 hour, guys. Don't forget, it's 15 degrees is 1 hour. So if we're going to move from C to D, D is going to be ahead. How do we know? Because we always rotate in that direction. Plus the little arrows here tell us that. So since we're rotating in that direction, C is going to be behind 2 hours compared to D. Since C is at 3 p.m., D is going to be at 5 p.m.
Okay, always remember, the easiest way to remember this is think of like the Western time zone, basketball games in California versus New York, all those things that we talked about. Question 35. If the axis of the Earth were not tilted relative to the plane of the Earth's orbit, so in other words, if the Earth orbited straight, Miss G will show you, versus tilted, okay, what would happen? Well, if it was orbiting straight, it means the sunlight that would hit it would be hitting every surface exactly the same, versus when it's tilted, Miss G, hold your hand up again, her fingers, if the sun is closer to you, okay, if the sun is where Miss G's phone is, can't see that. Okay, you can see the top of her fingers are getting lit up. This is high tech, ladies and gentlemen, okay, versus the bottom of her hand is barely getting anything, okay, but when it's straight up and down, hold your hand straight up and down, everybody gets the same amount of sunlight. Okay, so what does that mean? If the Earth's axis was not tilted, everybody would get the same amount of sunlight. We are going stir crazy being inside. We miss you guys. Okay.
36.
Length of an Earth year is based on, come on guys, come on. Okay, Earth year is the period of revolution. Okay, and the period of revolution basically is the Earth goes around the sun. How long does that take? 365 days. It's roughly a circle. How many degrees are there in a circle? 360. So, how far do we go each day? A little bit less than a degree.
Okay. 37. Which object orbits Earth in both the Earth-centered and the Sun-centered models? Okay, when you were looking at it, you don't even care about what it says. Which object orbits Earth? Stop. It's always the moon. If Venus was orbiting us, that would be a problem. Polaris doesn't move at all. It stays still.
Well, it moves, but
not really.
Not what we can see.
Right, and the sun moves, but not around us, no matter what. Okay?
38. Whoa, stop moving.
Sorry.
Which diagram best represents the motions of the celestial objects? This is basically the same question. Heliocentric model, which means, what's helio? Sun-centered.
And it also says it right there.
So the sun must be in the center of your model, so the S must be in the center. And the Earth must go around it, and the planets go around the moon. The moons go around the planets. So the only one that makes sense is choice number D.
39.
Which observation is a direct result of changes in the distance between the Earth and the Sun? Okay, well, this is easy. Miss G will show you this. Miss G, hold your finger close to the camera. Okay, now move your fingers away. Well, do it again. Close. Wow, we can't even see it anymore. Go away. Yay. So what happens to the apparent diameter of Miss G's hand as it moves away? Okay, it gets bigger or smaller. Okay, as we move closer or further away from the sun, we see this too.
Okay, so it can't be A because A says a Foucault pendulum shows predictable changes in the direction of its swing. That's going to happen no matter what. Okay, no matter if you change the difference, because remember that is just doing the rotation of the sun, of the Earth. Okay, the length of daylight at the poles change from 0 to 24 hours. No, that is not true. Okay, summer occurs in the northern hemisphere at the same time that winter occurs in the southern hemisphere. That is true, but that has nothing to do with the distance between the Earth and the sun.
Seasons have nothing to do with the distance between the Earth and the sun. It's all the tilt. Yes, very good.
Okay. The symbols below represent star masses and distances. So here we actually have to look at this. It says, which diagram shows two stars that have the greatest gravitational force between them? Well, when do they have the greatest gravitational force is when they are closest together and...
when they are big.
Okay, so the answer has to be D. So you could have narrowed this down to at least C and D and said, okay, those two are closer together, but it's also because when they are bigger.